Let's see. Are we live? I think I'm live. So let's see. How's it going? Cool. I am live. Yeah. Let me run the intro music because I don't know how to start a stream without it. Like, about the artifact. How about that? All right. I'm actually really excited about this because at the very end of the last stream, I looked at an exercise. Hey, that's not it. Hey, that's me. I need to get to open my YouTube studio. I just started streaming without even like planning this thing out. So this is how we stream. Oh, it faded out. I'm like, what happened to like something? Yeah, the music's over. I'm not going to play music during this stream because I was just rewatching the last one and thought it was like a little bit distracting. So how do I get to this stream right here? Live control room? Yeah, that's what I want. And now we get that out of there. So, all right. Cool. So yeah, I looked at, we don't need the Facebook. I'll get rid of that. Get rid of that. That sound of sorting. We don't need that. All right. I also did some more work on this earlier today. Well, actually, technically that was yesterday. So on the exorcism Twitch channel. There we go. Just a nice little fade into the thing. Yeah, on the Exorcism Live Twitch channel, I did some work. Made it into a proper script that runs. We're in Linux right now. And so now it works so that if you pass it a command line argument, actually we haven't hooked that up yet. I can get rid of this. Just don't need that. And I pretty much finished it earlier. See, it's a little off center. It's bothering me. See, all right. I think I did this afterwards. So we're now defining our data that we fetch from that URL just as a regular var instead of a function. That way we only have to fetch the data once and then it will live in this variable. And we have the Debseedin file, which works. We create the Leiningen file, project CLJ, the test namespace, the source namespace, all the testing forms, throw them in the def tests. And then this one does all the heavy lifting, which creates the test files and the directory structure. And we can see how that would work. Well, yeah, I called it on the Yacht directory, and this is what we have. Create the source directory. And we init the description, which the description is the instructions, which was really easy because that's just it's just a markdown file that we're fetching, and then slurp it. Yeah, we're fetching it with slurp, and then immediately just spitting it out to a new file. Which yeah, that's fine. And oh boy, so there's really no getting around this now. I'm gonna have to actually solve this exercise, which means that I'm gonna have to actually learn how Yacht works, and I am not a card or dice person. I just that does not make me excited whatsoever. But for the love of computer science, I will subject myself to a game. And this has never been solved in Clojure before. That's the whole problem. And I'm not used to solving exercises without answers to see. I could probably, there might be some way to cheat, like I am not going to ask the chatbot. Oh, that would just, no, I'm like so over the chatbot. Oh my God. Like, it's like actually making me like triggered. Let's go to the Wikipedia page and find out how. Well, first, do I want to go to Wikipedia first? Let's just go to exorcism. And for all I know, there might be a link to the Wikipedia page. That might be a strong possibility. And what I'll do is I'll just try to reverse engineer the exercise from the solution in another language. So which one would I like to do? How about JavaScript? And oh, I could even like try using the JavaScript to ClojureScript translator. That might be kind of fun. Yeah. So let's go to somewhere. How about I know the exercise is at least in JavaScript. So instead of having to find it, I'll just type it in here. Yacht. Is it like Yahtzee, maybe? Oh, it is. It's like it's from this. I know how to play Yahtzee too. I used to do that with my mom and my sister, I think. And yeah, it was like a kid's version of poker or something, where you have like full house and stuff. So the dice game Yacht, and oh, look, it does have a link to Wikipedia. So I'll go ahead and open that. We can, and oh, there's a cute little picture. It's a public domain dice game. Oh, thank God nobody owns the game. similar to the Latin American game Generala, the English game of poker dice, the Scandinavian Yacht. Guess I have to experiencing connection issues. Okay, it looks like we're good. Yacht dates back to at least 1938 and is a contemporary of the similar three-dice game Krog. Yahtzee is a later development similar to Yacht in both name and content. Well, that's interesting. I guess Yahtzee was just easier to capitalize on by Milton Bradley or whatever. These rules relate to the 1938 version of Yacht. The object of the game is to score points by rolling 5 dice to make certain combinations. The dice can be rolled up to 3 times in a turn to try to make these combinations. I think we're just dealing with one roll, right? A game consists of 12 rounds. After each round, the player chooses which scoring categories to be used for that round. Once a category has been used in the game, it cannot be used again. The scoring categories have varying point values, some of which are fixed values, and others where the score depends on the value of the dice. A yacht is a 5 of a kind and scores 50 points, the highest of any category. The winner is the player who scores the most points. Yeah, so this seems very similar to Yahtzee. Oh, it's been like so many years since I've even thought about that. So we have ones, twos, sum of dice with the 2 face. The sum, okay, so you would count up the ones, you would count up the twos, count the threes, so there's 3 threes, so which is 9. Fours, yeah, that makes sense. 5s, 6s, yep, I get it. Full house, that's 3 of one and 2 of another. And it always scores 25. 4 of a kind, little straight, big straight. Choice is just, okay, that's easy. It's just to add them all up. And yeah, that's pretty simple, actually. Okay, here's a handy-dandy comparison with Yahtzee. No upper section bonus. What's an upper section bonus? I've never heard of that. We probably never read the instructions. And no 3 of a kind. No 3 of a kind. Oh, there is not. Okay, whatever. Both straights are set sequences of 5. Okay. All right. So yeah, it's not like a shorter one. The small straight is just starts at 1 and large starts at 2, but they're both the same size. And no Yahtzee bonus or joker. Okay, yeah, so it's simpler than Yahtzee. Cool. Yeah, this isn't so bad. It's actually kind of fun. And here's the same thing that we just read, but in a table. 5 dice are rolled, and the result can be entered in any of 12 categories. The score of a throw of the dice depends on category chosen. Now, really, the point of me having to solve the exercise is to create the example file, which really what that is it's to prove that the exercise can be solved in Clojure, and yeah, to have something to test so that we know that everything is working and the exercise in fact can be solved. Cool, so that's all of that. If the dice do not satisfy the requirements of a category, the score is 0. sad trombone.mp3. If, for example, 4 of a kind is entered in the yacht category, 0 points are scored. A yacht scores 0 if entered in the full house category. Wait, so what is this saying? Oh yeah, if a 4 of a kind is in the category of yacht, that's 0 because that's like illegal. So too with a yacht in full house, it's just not a full house. So the task is, given a list of values for 5 dice and a category, your solution should return the score of the dice for that category. If the dice do not satisfy the requirements of the category, your solution should return 0. Okay, a list of values and a category. And yeah, this is actually really easy. Why did I say that? I blew it. You can assume that 5 values will always be presented, and the value of each will be between 1 and 6, inclusively. You should not assume that the dice are ordered. Okay. So yeah, in order to as much as it would be fun to watch me struggle through it, I also would not know if I am solving it in any sort of idiomatic fashion. Of course, idiomatic in Clojure is going to be different than idiomatic in JavaScript, but the process for solving it will be similar, I'm sure. You know, it would actually be better to maybe use a functional language, but you know, it would actually be harder for me to understand a solution in like Haskell or something. Although maybe not. Maybe Haskell might be good to look at because it would solve it with pure functions. That's an interesting idea. Where is the JavaScript repo? I had it open, I thought. Okay, whatever. You know, let me check out Haskell real quick. You got me curious. Haskell has lots of exercises, so it's bound to be here. Yes, it is. And they have zipper, which, oh my god, this is what I am so excited about. I actually just want to like finish this exercise so that it's done and then get on to zipper because, oh my god, I can't even wait. I just have to is zipper in JavaScript? Yes, it is. So I can't believe nobody told me this was here. I'm like I'm a zipper girl. I use zippers all the time. In fact, we used them on this stream just a couple of days ago. I looked at this. This was at the very end of the last stream I did on here because I realized that I would need to likely expand the generator in order to make it handle other exercises like the zipper one. And I just looked at it real quick without even realizing what it was. It's a zipper for a binary tree, and zippers are a purely functional way of navigating within a data structure and manipulating it. So yeah, if you have seen any of my streams where I've been using rewrite CLJ, we've used zippers because, well, there's a Clojure implementation of zippers, which is amazing. And I always heard people really praising the source code for the zippers, which Rich Hickey implemented following the paper by Huet. A zipper is a technique of representing an aggregate data structure so that it is convenient for writing programs that traverse the structure arbitrarily and update its contents, especially in purely functional programming languages. The zipper was described by Gerard Huet in 1997. And it's really cool to actually check out the paper. I think it's written in OCaml. Functional Perl the zipper. This is it. And yeah, if you the doc string for the zipper source code in Clojure actually just says C Huet, very like cryptically, if I might say. And there was a presentation on zippers by Arne from Lambda Island called The Art of Tree Shaping. And he said it's a very Hickeyan docstring in that it makes perfect sense as long as you already know exactly what he's talking about. But yeah, I always heard that it's a really great example of a use of metadata in Clojure. And as we explained before, one of Clojure's strengths is that you can have arbitrary metadata. So we're going to look for, yeah, so, but when I finally did actually look at the source, I felt silly that I had never actually looked at it before, because it really is amazing. And really simple, actually. It's like really simple. Clojure zip. That's yeah, here's the API documentation. Yeah, it just says functional hierarchical zipper with navigation, editing, and enumeration. See Huet. And it's like okay. And it took me so long to figure out how these worked, because like we used them in Clojure for stuff like parsing things like XML. There's an XML parsing library that uses zippers, and I couldn't figure it out for the life of me. It was like, I hate zippers. I hate them. Until I saw a video by Oxalorg. I can't remember his name. He also works for Lambda Island. Oh no, I can't remember his name. What shall I do? Anyway, I don't want to get too off track. We need the source. Where's the here we go. And yeah, this is just amazing. And the thing is well, this is like, it actually seems like kind of a big exercise to implement a zipper. I mean, that's, yeah, oh, it says hard. Yeah, it's a hard exercise. Cool. And the thing is I might want to try to solve it without using metadata. I don't know if that's I don't know, we'll see. But anyway, I'm getting ahead of myself because I have to do Yacht first. I was just wanted to talk about that because I'm like really excited about porting zipper to Clojure after this. It's like, nobody told me there was a zipper exercise. Zippers are like my yeah, I'm a zipper girl. So, Yacht has Haskell. Let's see what that looks like. I like just started learning Haskell, and I was actually really surprised how much it's like Clojure. Like, I mean, that is like, I mean, Clojure is really a functional language. It just has escape hatches so that you don't need monads. Success standard. Okay. But you know, I can't, I don't think I can really read Haskell very well. So then we have some data, and there's the different the different things, the categories they're called. And here's like some kind of function and the value score. What's value score? Value score 1. Join the filter. Yeah, that's Haskell people are probably laughing at me right now if they're watching. And I mean, no one is, but I mean, like in the future or something, because this looks like it's probably pretty simple if you know what it means. I'll check out the JavaScript one because it'll probably be more straightforward to follow, I imagine. So yeah, I'll just copy this. And change this to JavaScript. Wait, that's not going to work. Oh, actually, it probably will. Yep. Oh, that's instructions. We need meta. The proof. Yes, that. Oh, wow. This. Oh, that's kind of. This is more complicated than I thought, isn't it? So let's see. JavaScript to ClojureScript translator. This will be my best friend. I have it here. All right. Oh, where did it go? Put this over here. Let's see. Get score for the yacht category. First of all, let's see if we can get really, really, really lucky. If I just paste this in and it translates it. No, it doesn't. Oh, it's just because we don't have import, which is fine. That's fine. It's fine. We can just take export away. Oh my God. Look at this. This is amazing. Oh my God. This might just work. Mauricio, you are my hero. Okay, calm down. I can't believe it. This might just work. Let's see. Yeah, so this here, that's the function stub that we created. There's the score function, which I'll paste this stuff here. That's the score function. All right. And let's see if this works. Let's see. We need the I am going to, actually, I need to create a new branch here because something weird happened and I don't want to talk about it. No, it's like a generator. I it probably needs some explanation, or like you're gonna think that like something is something actually really embarrassing or something. Not, it's just I lost the branch somehow and I don't understand how. Okay, so first of all, we would not name functions this way. Instead of get score for the yacht category, I will just say yacht score. Let's just let me just see if it works first. No, yeah, I don't want that. Let's say no, I want to leave the I want to leave the names first so that I don't have to worry about changing them. So if we have the dices, I thought dice was plural, the plural of die. So is yacht looks like, okay, we have a predicate function where we're taking the size property of the set of dices. Yeah, so if the set is 1, that means they're all the same. That makes perfect sense. Except that's not how we do that. We'll just say set dices, and then that's not how we do that. We do count. And that should do it. And then, okay, so if is yacht, then that, otherwise 0. Yeah, so that makes perfect sense. So I'm just going to simplify this because we don't need this. We'll just say if that do. All right, we are done. Did I do that already? Okay. Map dices to counter array. Why would we do that? Okay, so we have a counter array, which is just initialized to a bunch of zeros. And do we need that? No, see, this is probably not the way to do it in Clojure. We're mapping the dices to a counter array. Yeah, so like to do it in like an imperative way. Okay, so this is it's like creating a JavaScript array. Yeah, which is right here. What I could do just to get this working is use an atom. Up an atom. Just an atom. And yep, do seek. And now we're getting the decrement of the item. And okay, so for each item in the dices, so what is that doing? It's just it's not modifying the counter array. It's wait, so if we're getting okay, so this is like a stateful thing that is going to be modified by something else or something. Let's see. It's like creating... What is this thing? I have no idea what that means. It's like creating an object. I'm going to have to look at the actual JavaScript and hopefully have some idea of what's going on. So we have the counter array and the, oh yeah, see, this is very easy. It's just, okay, it's incrementing. Wait. Oh, my stupid is showing. It's taking whatever item of the array, the decremented item of the array, and increasing that one. Yeah, that's all. That's all. It's just taking the decrement of whatever item, and we do that for each, and increasing that one. Okay, that should be super easy. This syntax just confused me. Like, why would they do it like that? And wait, yeah, this doesn't seem right. Here we're getting something. Oh, I guess this is like modifying it or something. But okay, so let's just get rid of that because it doesn't make any sense. We'll say deck item instead of item -1. And we're going to swap the counter array and by returning a new array with that, okay, is gonna have a function that will we'll take this out here and work with it. So let's say that's our counter array, or vector rather. And let's say we're on the first iteration. So the item will be so the item is the value of the die. Wait. I'm confused because is it taking the I need an easier way to switch windows. Item -1. So for let item of dices map dices like 3, 4, 5, 6. Okay, because it's to keep track of the numbers for the scores of the dice. Okay, I think I get it. So yeah, it's not keeping track of the scores of each of the dice. It's which each of each number. So which die has like a 1. So if the first one is like a 1, well, we would decrement just because it's 0 based, and that makes sense. So that 1 would be stored as the first element. Okay, that makes sense. Yes, I totally get it. So we're swapping the counter array. Yeah, let me talk through this again. This is so easy, but my head is so thick that takes me forever just to figure out the most basic things. But so let's say we roll a 6. So the first item is a 6, which means we need to increment the last one. So if let's see just how that would happen. We would say update. Yes. We'll update the vector. Because a vector is an associative data structure. And it will be whatever the key is the index. So it will be dec of, if we rolled a 6, then it would be a 5. No. Yeah, dec 6. And the new value will be, well, it's the map, and then the key, and then the function. Yeah, so it will be inc. That's how update works. Yes. Cool. That's exactly exactly what we would do. And so that would be passed to swap, which would be here. Update. The I always get confused on the syntax for swap. If we're going to call, let's see, update, I actually need to look at the documentation for swap again. See, how silly of me. Closure, swap, see what order it works to do what I want to do. Like here, we swap atom x, the function x, y, and the rest of the args. Let's see if there is an example with update or something. We don't need update in because it's not nested. Yeah, here's an example. Update. Yeah, we just put swap whatever the data structure is, then update, then the key, and then the function, and then that. Let's see. Yeah, so we don't need that. We'll just say swap counter array, update, and then it's going to be inc. Wait, I forgot the order already. Let's see. It's update. Yeah, the key first. La 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 la. So update. Here it's going to be deck item. And so let's demonstrate how that would work. Actually, let. Yeah, that's right. Yeah, so let's show how this would work, where we have our counter, which will be an atom that is this vector of the score. Define that. And then let's say we want to swap the counter by updating the which key. It would be like, just say 5, whatever, and increase it. And yeah, we can already see that it worked. Cool, so that should do it. Let me prove it. So we call this on, let's see. So if it's going to do that for, so we have how many die? 5? Or let's just put some random numbers in, I guess. Well, they're dice. So 1, 5, 4, 2, 3. How many were there? I guess it doesn't matter. And cool. So yeah, we have it's for 1. There's 1, 1. Does that make sense? Yeah. 1, 1. Wait, no, this doesn't make sense. Because there's more than 1, 2. Oh, no, there is just 1, 2. Okay. There's 1, 3. And there's 1, 4. And there's 1, 5. And there's 0, 6. Cool. So I think we're good. Except that's probably not how I want to do it ultimately, because we probably don't need to have like a stateful, we don't have to use state. I'd rather do it functionally. But I'm just excited to see if I can actually get this working. Or for those of who might be just joining us, we we used the JavaScript to ClojureScript translator in order to cheat, which is because it's unlike me to do an exercise without cheating. So I took the JavaScript solution, and I can't believe it actually like sort of works. So here, I'm going to change length to count, and I guess that really, yeah, okay, filter, just like JavaScript's filter is similar to so we filter, except the predicate function doesn't go there, it goes here. And it's just testing equality. Is that all it's doing? Testing whether the value passed to it is equal to the dice value passed in. And get number of appearances. Oh, okay. So it's just a query function that will say how many of whatever value we want is in the thing. So let's try that. Number. So let's say our dices are 1, 2, 3, 4, 5. How many are there supposed to be? 5? I think, yeah, it's like Yahtzee. And let's say we want to know how many 2s there are. Is that how this works? And yeah, there's 1. Okay, good enough for me. What's next? Get sum of dices. And, oh, yeah, okay. Reduce dices by adding them to... Why is there just 1? Oh. It takes 2 arguments. That's the initial value, right? For reduce. That goes... Wait, how does reduce work again? Oh, I don't need to go there to get the order of arguments. I can just use these pop-ups that I love so much. I actually don't. But they're so useful. I'm so torn. Like, I want to turn them off because I hate things popping up in my face, but but it's actually useful. So yeah, it's the function, and then the value, and then the collection. So yeah, just like I was thinking, function, value, and then, wait. Reduce. Yeah, this goes, yeah, okay. It goes here. Wait, no. There we go. And it's just adding them all up. Couldn't we have just used reduce plus for that? Like without I think so. If that's all we're doing is yeah, okay. Well, that's easy. Just that's all we had to do, right? Yeah, okay. Apply plus would also work. The 0 doesn't technically need to be there, but it's recommended to always use an initial value for reduce. I forget exactly why, because I think there's weird edge cases, like if there's only one thing or something. So get score for the 4 of a kind category. So this has another counter array, which, so we map the dices to the counter array, which we defined over here. And that gets defined as the counter array. All right, that makes sense. And then, okay, so this is like a loop where it's initializing I to 0. And I'm probably going to not do it that way. So, yeah, what is this doing? I don't understand this sequence here. Has something to do with the loop. So I actually need to look at the JavaScript, which will make more sense than that did. So here we have this. Here it is. That doesn't move. So we'll say... So yeah, it's just a for loop. But for some reason, this translates it funny, which I'm not going to complain because it's like a miracle that it even did this much. I was like ecstatic. So yeah, we are defining a constant, which is the dice's mapped to the counter, which just tells us how many of each number there is. And then we loop through it, keeping track of the index. And if that index of the counter array is greater than or equal to 4, yeah, because it's telling you how many of each number is in it. Then it scores that. So it multiplies the index, well, increments the index and multiplies that by 4. And then what is return 0? Why would it? Oh, okay. That's yeah, because if there are not actually a 4 of a kind, then it's like an illegal 4 of a kind, and so that's the score is 0. That makes sense. So I can write this a little better, I think. Because, yeah, I don't think we're gonna need that. We would just do like 4. So what that would look like would be like, so 4, and we're gonna like iterate over a range. So we'll say for each, not for each die, it's for each score. Does that make sense? No, for each, just call it value, or just V, maybe. No, I'll just use I because that's what it was. And for each index in the range of, we know that it is a length of 6. And yeah, we just iterate through it, so we don't need that. And yeah, this is just a mess. I don't even want to look at that. Say, All right. So what do we do again? Yeah, my brain is like sludge. Um, Here I am again doing a late night stream when just because I'm too excited to not. So yeah, what are we doing again? Maybe I will try to be smart or something by writing this down. So this is get score for four of a kind category. Where we, oh, this is annoying, but yeah, just want to see them both. Okay, let's see. So that takes all the dices, maps them to the array. And which is going to be assigned to counter array. I'm probably going to do this and then it's still not going to make sense to me. But even though it's so simple. But, then we iterate through the array. And for each index, test if I of counter array is greater than or equal to 4. If so, return 4 times I plus 1. Else 0. So simple. There's no excuse for this to not be simple. All right, so for each index, 1 through 6, and so we're testing whether I of the counter array, so to get that value, that index of, yeah, we could use get, I guess. Whoa, what just happened? Windows is sticky keys. So if it's greater than or equal to 4, I plus 1, so inc I Wait, I just totally messed that up. If I is greater than or equal to 4, then we return... Does this even make sense? This would probably be actually easier to just try to solve it myself. I think I'm getting more confused by trying to translate it from the JavaScript. Because I actually just need to think of what are we actually trying to do here. I guess I'll finish this and see if it works. Well, so if so, then we will return this. So our result of multiplying 4 times inc I. I guess that makes sense. Otherwise, it'll return 0. Oh, wait. We're not doing anything with this. What are we doing with this? Counter array. I got ink. Wait a minute. If the index of the counter array, yes, okay. Get counter array I. And now it should probably work. All right, so let's say we roll a 4 of a kind. And this is going to get the score for it. So the dice, let's say we have 4 5s and a 3. And it didn't work. Okay, so I wonder why not. Yeah, this is like this has got to be like way simpler than because this is like doing it imperatively, which that's why I'm getting confused, because I'm not used to thinking imperatively. So let me just try to take a step back and think of we're just trying to return the score for 4 of a kind, which is what is the score for 4 of a kind? I forgot how it works already. Let's say where's the directions for the 4 of a kind is the total of the 4 dice. So yeah, we take the value and add them up. So it's going to be 4 times that index plus 1. So in this case, we would return 20. That's 5, 10, 15, 20. So let me just think about how I would do that. So yeah, this version is taking each of the values 0 through 6, or 0 through 5 actually. It's actually fine, I think. I just need to figure out why it didn't work. So, like, we got an error, but I don't know why. So let's say, here's our dices. I don't think dices is actually a word. Let's say, we map the dices to the counter array, and let's see what that, see, we might have a problem with that because it's using, yeah, we need to deref the atom. Right? No, we need to deref it here. Wait, no, it's right. Yeah, okay. That might be the whole problem. No. Let's see. Now what's the problem? Oh, because I didn't do it here. Cool. That looks right. Right? That's not what it's supposed to do. Because it's like the if is supposed to just be on the outside of the loop, I think. Wait, I'm getting so... I probably shouldn't be trying to code right now. But that's no excuse. Let me look at the JavaScript solution again. I kind of knew this was going to be hard. Is this exercise supposed to be hard? Let me see what's the difficulty. Medium. Okay, I guess I don't feel that bad. It's just I'm always way too hard on myself, and as if like I'm supposed to just immediately know how to do stuff. Oh yeah, if I think about this for long enough, there's probably a way simpler way to do it. I wonder if I can just find a solution. I'm not going to ask the chatbot, just out of principle, but let's see. Yacht solution closure. This is so cheesy. I should just I guess yeah, I might be on my own. Anyways, this is it should be so easy. I'm just I'll look at look at the JavaScript solution again. So to get the score for the 4 of a kind. Yeah, so the test is inside the for loop. Like, why is it returning? Yeah, I think it's doing the right thing. I'm just confused because aren't we just supposed to get one number? Get score. Like, it should just be returning a single value, right? Not a sequence of values, but we're going through all of the values. And if that one is... So yeah, if I do this in JavaScript, let me open up a JavaScript. Let's see where this function is called. What calls get score for the 4 of a kind? Yeah, so it's passed in by the test case. Okay. Then it just yeah, I don't understand why this works. Because it seems like it's returning if it's never wait a minute. Yeah, it's iterating through it. And returning a sum. Let me look at that. Like, how is this the score? It was supposed to return 20. 5, 10, 15, 20. This is kind of a boring stream. I'm just like, durr. I'm more excited about the zipper one, but now it looks like I'm not going to get to that today anyway. It'll have to be next time. But this will be worth it because this is the exercise that somebody requested. So get the score. Yeah, so how is... It's iterating through the counter. Like, how does that give us the score? It gives us an array of the score for each one of the numbers. But we don't want each of the numbers. We want just the one that Oh, okay. It's not putting it in the array if that. Okay, I think that makes sense. So if, you know what, this is backwards. That's, that was the problem, I think. No, that's, I did it again. Just to get rid of this. Okay. All right. So, we don't want the 0 here. We want another test. And this can be a when, which is just an if without an else branch. So we would just say we have that, and then we get nils, and then we can just get rid of the nils by we can just say keep. I think that's what keep does. So we would say no, I guess that's I'll just say remove nil. Then we get 20. And we will test if it's empty. I will just put this in here as another binding. So we will say scores, I don't know. And then over here, we'll say if it's empty. Then we will return 0. And otherwise return the first of the scores. Oh, yeah, this is, I did this wrong. Okay, I think that should work. So that returns 20, and then let's say we don't have 4 of a kind. We want this to return 0. Cool. All right. I'm not a total dummy. I'm just really, really slow. I still, I'm sure there's a better way to do this without having to iterate like imperatively and without having to use this stateful atom. But whatever, it works. This is all just to prove that the exercise is solvable, which obviously it's solvable. If it's solvable in any language, we can do it in Clojure. And to just to provide to serve as a for the test, so that we can test that everything is working. So what is this doing? This, as usual, it looks all funny because it's converted JavaScript from the translator. So we did 4 of a kind. Now we have little straight, which is not like the little straight of Yahtzee, which is only 4, only 4 numbers. It's 5, but the little starts at 1 and the big straight starts at 2. So if it's a little straight, I can't read this. Not can't see all of it. Okay, that's really tiny, but there we go. Cool. So it's a get score for it's an arrow function. Okay. We have the counter array, which so we map the dices to the counter array, which makes sense. That's yeah, here. That makes sense once we put the @ sign here, because it's an atom. We need to dereference it. And okay, is little straight. And so we have array is filled with value. What? Where did that come from? Oh, I guess we have hoisting in JavaScript, which means the functions can be written out of order. So indeed, it's over here, which means we actually need to define that one first. Array is filled with value. Oh, what is this doing? It's a predicate function that takes an array, the starting position, the ending position, and the value. Wow, what do we need all of that for? So we're iterating through the indexes from the start position until we get to the end position, incrementing it each time. And if that index of the array passed in is not equal to the value passed in, okay, so it's if it is not array is filled with, okay, so it's testing if there's any that are different. Start, what about the start and the end position? That's it. So it's like okay, let's see how it's being used. So it's this here. Array is filled with value. Okay, so that's what all of these arguments mean. So it's the I can put this over here where it should be. So that I can see both functions. So we're testing whether the counter array from 0 until the length -1, which that's just accounting for the zero-based indexing, so that the first element is 1 until, wait, and the value is 1. Okay, so yeah, we're testing whether there's a 1 in it from no, that's return is little straight. Yeah, okay. Okay, so I think I understand what this is. Wait, do I understand how this works? Let me see. Array is filled with the. Does filled mean like that value exists in it? I guess, or that. But that would. I would have worded that. If that's what it means, I would have said like array contains value or something. If that's what it's testing. But array is filled with value makes it sound like that if it's filled with the value. So yeah, I'm a little bit confused on that. But also, why do we care about from the starting position to the end? I guess because we're using this probably elsewhere. Yeah, like for the big straight, we're testing it from 1 to the length of the array. Okay. And let's see if it's used anywhere else. No, I guess not. So yeah, it's just a function for testing whether there is a straight. And yeah, it seems like there should be an easier way to do that in Clojure without like we would just test whether I mean, couldn't we just like if the little straight is, it's like a given set of values. Can't we just test if it is those values? Like, okay, like, hear me out. A little straight is just this, right? Let me look at the rules again. Yeah, it's just 1, 2, 3, 4, 5. So what's the problem? Can't we just test if the array is 1, 2, 3, 4, 5? Why would we have to do all of that business? You get the score for the little straight category. Like, why do we need to do all of this? I could just say like, why, the dices are passed in. I mean, can't we just say like, equals dice is 1, 2, 3, 4, 5. Like, can I just do that? It seems too easy. This can't be right. So we would say if, whoops, why did I have a K there? If that is true, then the score is 30. And if it's not that, then it's 0. Why would it have to be any harder than that? There must be something I'm not understanding. But it seems like it's either that or not. Just you could do that in JavaScript as well, right? Yeah, I mean it's easy to maybe not. Yeah, of course you can test whether an array equal. Do you have to iterate through it just to find out if the values are what? Maybe I'm spoiled by Clojure. So I would imagine that this one could be solved likewise by just something extremely similar. It's gonna do, except it's gonna be 2, 3, 4, 5, 6. Then it will, if so, it scores 30. Yeah, so just prove that this works. So get score. So let's say we have 1, 2, 3, 4, 5. Then we get 30. Yes, this is like ridiculous. Otherwise, 0. Yeah, I don't know. I'm still like shocked that it would be any. I'm skeptical because it seems like that's too easy. Oh, Paper, what's up? I'm proving how inept I am at solving a simple exercise. Well, it's not simple. Technically, it's medium. But and this is Clojure code that has been automatically translated from the JavaScript solution. Except that it like translated it to like weird JavaScript. Like, what does this mean? I have no idea. It's like something about iterating through a loop. So, oh yeah, so that's the array is filled with value function, which we don't need because that was only used for those other functions. Okay, so bye-bye. Okay, so let's say we have a full house. This one might get interesting. And this is weird. So let's see what it came from. Get the score for the full house category. Takes our dices. I don't think that dices is not a real word. And, I had a math teacher that also used to he like had die and dice like switched, so he would say die when he meant like plural, and it's supposed to be the opposite. So like dice, it should just say dice, but whatever. Isn't an English problem. So we're mapping the dices to the counter array, which keeps track of the values. And here are two mutable variables, which we're initializing to false. So we're going to be testing whether there's 2 of a kind or whether there's a 3 of a kind. So yeah, that seems pretty simple. We iterate through them, and if that item is equal to 2, how does that make sense? We are yeah, because when we map the dice to a counter array, yeah, that still confuses me a little bit. Because at that point, counter array is not the scores, the actual values of the dice. It is the counter of how many there are of each value. So yeah, that makes sense. So let's test whether we have a full house. And our counter array thing map was the first thing we defined. And yeah, so that defines a local atom. So yeah, that's what I was just thinking. It's not global, so we don't have to worry about it being like dirty. So we have our values, and we're not going to need this. And yeah, I'm just gonna get rid of this because I think the closure answer is going to be easier, actually. I mean, this sure was. I'm still skeptical about this, but I don't know. It works. It's I just in JavaScript, you seriously can't just test whether an array equals another array. Like that's impossible. I mean, without like actually having to set up a loop and iterate through it, testing if each value is equal to I don't know, maybe I'm having trouble accepting this. So yeah, we don't need these, I don't think. So let me think about how I would do this. We just need to test whether there's 2 of something and 3 of something. So like, wouldn't that just mean, okay, so let's say we have, also we're going to need to dereference this, remember? All right, so let's say we have a full house, like it would be like 2, 2, 3, 3, 3. All right, full house. And we map it. So yeah, I mean, this is like ridiculously simple. We just need to check if there's a 2 and a 3 in it. That's all. So we can just say and for logical and so we'll say contains, get out of my face. I hate these pop-up things. It contains a 2 counter array. I guess that's backwards. Okay. Or wait, how does contains work? Now I want the pop-up. Oh, thank you. Oh, I hate you. Thank you. I hate you. Takes the collection and then the key. Okay. And good. So if that and that, that's all. I mean, fight me. So let's say I didn't want to do that. I didn't want to do that either. All right, get score for full house category. And for that. Okay, so yeah, we're not getting the score yet, but what is a full house score? It scores 19. Okay. So instead of true or false, we just we can say if that, then 19, else 0. And we get 19, and say we don't have a full house. Oh, wait a minute. Wait a minute. Why is that returning 19? So if the counter array, so if we map the dices to this counter array, there's no 3 in it. So why would this be returning if same it's we're not using or, it's and. Well, let's say our counter array is this. I didn't want to do that. Okay, this should return false. What? Okay, wait, what's going on? Why is that? Wait, because we need to map. We're testing that, not that. Okay, it still says true. Why is that? This is should be returning false. What? Oh, I just inhaled my hair. I just inhaled my hair. That was actually the funniest thing that happened this entire stream. Contains doesn't do what I think it does, and I can't believe I messed that up. it's checking for the existence of an index 3. So I guess what we want is like some wait, how does some work? Returns it some predicate we can just turn it into a set. We can use a set. Yeah, we use a set as a predicate. So let's see how that works. Or maybe it's the sum with the question mark. Whoops. It might be the sum with the question mark. Why isn't it showing me the doc? Oh, it is. What is the one that where you use a set as a predicate and it tests membership? It's like another like really simple thing that I can't seem to solving exercises is hard. All right, yeah, which one? Let's go over to closure docs and check out sum. And see if this is the one I'm thinking. This is the same thing that it was just showing me in VS Code, but yeah. Wait. A hash acts as a function, returning nil if it's present. Oh, it's for when the key is not present. And the key value, is that what I want to do? Let's say, and the key value otherwise. So, if the key is, what is like a simpler way of testing membership? For some reason, I should know this. Like, let's look up contains. It's probably going to send me right back here, I think. Contains. Can be used to test set membership. Wait, so how? The members of a set are the keys of those elements. Oh, okay. Yeah, I think that makes sense. So it would just be like this, but turn it into a set? And then put it the other way? Like, Wait, no, that's not even right. The set goes first. Yeah. So does that do it? Okay, then say there is not a 2. Okay. Yeah, that's all I had to do. Oh my god, that just like took me way too long to figure that out, but whatever. What did okay, so I just need to turn the counter array into a set here, and then that should do the trick. All right, so cool. So now it returns 0 because that's not a full house. Excellent. If we change this to a 3, then it returns 19, which is the score for a full house. Yay! Oh, speaking of full house, I was just I was just looking at Full House. It was the episode where Michelle sings "T for Two," where they were tap dancing. I can't show the clip because it'll probably be like I can't get like a copyright strike. But it was hilarious. Why was I thinking about that? It was T for Two. I looked it up because somebody was talking about something. And I also watched the performance by Doris Day. I guess it was like the musical. I think it was called T for Two. It was a very famous performance. It was really good. I can't remember why I even thought of that. But yeah, so it's like plus yeah, it's weird. It's weird watching Full House now because like all I can think about is how like unethical that whole thing was about like about hiring twins because the like child labor law with acting is like there a kid is only allowed to act for to work for like a certain number of hours even if like their parents are down with it, and so that's why they had twins is so that they are exploiting that part of the law. And well, and we know that you know that those poor girls, like oh my god, like didn't get to have a normal life. So wow, we're almost done. Like oh my god, this was like we're just at the final like dispatch function that is just going to dispatch on the category and call the appropriate function, which this looks fine. Right? No, wait, what is this 0 doing here? It's like the else branch, which, yeah. Yeah, okay, wait a minute. I think the 0 needs to not be there, but here. Because it's like the, it returns 0 if none of these. Why would it put it the other way? Oh, because like that's how JavaScript works, where you have like a loop or something. Let's look at it just to yeah, you have a switch statement, then all of the cases, and then it returns 0 if yeah, and so the closure case works different, so we do it that way. Wow. So I guess I'm ready to like run the tests and see if this actually works. That would be nice, but I'm not getting my hopes up. All right, so that's the source file. Here's the test file, which we generated with our generator. And okay, here we go. Evaluating that. Okay, there's an error already. Why? Maybe because I didn't. Yeah, I need to evaluate this whole page. And yeah, then re-require it, I guess. And there we go. Okay, are you ready? We need to require run tests. I'm scared. There's 3 failing ones. Okay, wow. So that's good, actually. It just means there's probably some edge cases that I haven't caught. Cool. So but in order to find out what they are, yeah, this doesn't tell me which one's failing. So I'm going to close down my REPL. Sounds like I was like trying to avoid saying kill or something for some reason. And I'm going to restart it using regular closure because I think that will give us more information. And yeah, plus, yeah, we needed to test this anyway because we need to see if the configuration file works. All right, so that's jacked in. I'll have to evaluate this and evaluate this. Okay. Now here we have 3 failures, and here it tells us which ones they are. So if the full house has 2 small and 3 big, all right, so it's testing whether, why would it return? Did I just, I might have just messed up one of the numbers because, oh, wait, no, they both, the full house, wait, why was it 16? Let's see, why would, if a full house is 19, why are we testing if it's equal to 16? Oh, because it is equal to 16. Why? Why would that, why is our full house function returning 16? That's genuinely weird, isn't it? Full house, get score, yeah. Huh, so why would that be, why would it be returning 16? Maybe, All right, let's trace it. We'll step through it ourselves and debug this. So here is our score for a full house. Did I hit copy or not? Okay, so where's our full house function? And it's returning 19. Okay, so there's nothing wrong with that. Why would why would it do score? Wait a minute. I think there's a mistake in the test suite for some reason. Yeah, it is expecting 16. What? That's not what it says. Full house is supposed to be 9. Okay, let's check the JavaScript test suite. Or no, let's check problem specifications. That's where we got it from. Why did Yacht have to be the very last one? Wait, is that the... Oh, no, I think that was there before. I thought maybe we just got a new exercise. All right, so what's going on here? Ones, twos, fours, threes, fives, six, full house. Expected 16. Okay, what is going on here? Why is I am so confused. It's not supposed to return 16. Well, at least that means that our test generator worked. So I'm not doing anything wrong. It seems like the specification is wrong. It doesn't match the instructions. 4 of a kind is 16. Not a full house. I am so confused. They would not mess that up because the problem specifications repo is like it's the most contentious aspect of exorcism, period. Just because everyone that cares about it really cares about it. And so this repo was locked for the longest time because it was just creating pandemonium. Which is why I'm having a hard time believing that there would be a mistake in it. This would have more eyeballs than like anything. There it says right there. Unless I don't know, if I am like totally confused or something, then I guess what I'll have to do is ask a question on the forum. But anyway, rather than spend the entire rest of the stream trying to figure out if I'm just going insane or something, more insane or something, I'm going to actually table that for a second and look at the other failing tests and see what's going on with those. So we have, it's for the straights. The straights are not okay. The straights are not okay. They're not passing. Straights don't care if they're passing. Okay, so it's supposed to return 30 because, oh, all right. Okay, I have just understood something. That's why they were more, yeah, okay. The functions for determining a straight were more complicated, and I didn't understand why, and now I know, because they're not in order. But that means that I can just fix it by sorting them. So, yeah, all I have to do, right? Yeah, is sort dices. Yeah. Reevaluate that. Sort those. Okay, now I'll evaluate this whole file. And yep, we just have the one failing test, which is the one that doesn't make any sense because, oh my God, like why would this, let me check, look at the other exercises that have this, and we'll look at the test suites. See if, yeah, at this point, like I'm probably going to have to ask a question on the forum and find out if like that's actually a mistake. Okay, so Full House. What is this doing? This is weird. No, see, actually, this is cool. This is what Haskell is doing. I don't really know Haskell, but it's like Clojure. It's just which is different syntax, basically. And you can't do certain things like impure things, but we're just adding them up. I don't know what join is or join filter. Saying that which one is not to. Whatever join is, it's probably something cool. But huh, this is a really cool solution. I don't even understand it, but I like how elegant it is and how much shorter it is than the JavaScript one. But oh yeah, I want to be looking at the test suite, not that. So yeah, let's go back up here. And I have no idea what Haskell tests are supposed to look like. Oh, this is simple enough. Yeah, it's just the XUnit spec, but written differently. What else would it be? So, Full House, 16. What? Okay, what is... Apparently, the directions are wrong. This has only one kind of full house. So yeah, now I'm gonna have to like put in a pull request to get this changed because why would this be? Okay, let's see what we're gonna have to look at the directions for the other exercises. Yeah, I can't believe I ended up finding a mistake. I mean, unless like I'm wrong, But no, I don't think I'm wrong. This makes sense for me. And any of y'all listening out there, like, am I taking crazy pills? Okay, so the let's look at the instructions for this and see. Full house. Yep, it says full house is unequivocally 19. Yeah, that is not right. Okay, let's look at the directions on Wikipedia. So that's right here. How nice of them to put that there for us. So here, full house 25. This has like different rules. Varies on different rules. Okay. But yeah, so why that's pretty confusing. We need to okay, so the problem would be in the problem specifications, which the directions are pulled from well, I just did that and then didn't even look to the instructions are pulled from here. And full house is supposed to be 19. Okay. Yeah, I think I found a mistake of yeah, just like yeah, tell me if this thought process makes sense. So here in the instructions it says that a full house is 19. And that's but then if we go to the test cases, and then we go to full house, and saying full house 3 small, 2 big, they have expected 19. And then here they have 2 small, 3 big. What is the difference? What does that mean? 3 small. Oh, okay. Yeah, that makes sense. So yeah, it's giving 2 different scores for full house. I mean, yes, this is like it's totally wrong. Wonder, does anyone know the rules for yacht? Like, have you ever heard of? Because it didn't say that on the Wikipedia page either. It just said that it varies for different rules. But yeah, apparently, I'm gonna have to ask a question on the forum here. But anyway, that means that besides this, we're done. Except that if it's the case that the directions are wrong and not the test cases, which I am I'm suspecting that that's the case. Otherwise, we wouldn't be testing whether there's 2 small and 3 big or 3 small and 2 big. We would just not. We would just not. So, which means I'm going to have to implement that logic for. So I'll go ahead and do that. So, okay, means that's a little more complicated. So for full house, how do we tell if, because this is just testing whether there is 2 of something and 3 of something. So what I could do is, all right, I'll make 2 array. Let me copy the test cases for this. So there's the 2 small, 3 big, which is supposed to equal 16. And here is the 3 small, 2 big, that's supposed to equal 19. I mean, that is kind of cool that it makes it a little bit harder. But they didn't update the instructions to reflect that. And all right, so I imagine we will sort it just to, I mean, that one's already sorted, so there's no point in even, we would, actually, we can use the function, there's a function called frequencies, which, oh, wow. What a great idea. Wow, I'm so smart. we could just use frequencies, right? I mean, so that we won't even have to do anything except where's our full house function? Like, instead of doing this, I think we could just use frequencies, because this tells us that there is 2 of something, 2 5s and 3 something, and 3 3s. Yeah, so then we just need to find out find out if there's 3 small, or so whatever is, we'll take this map, which is the result of the call to frequencies, and we will okay, how do we do this? We'll take we need to sort it by something. Think I can't think if I'm trying to think. We need to find out. All right, there's a 2 and a 3, so we know it's a full house. We need to put, is this guaranteed to be in that order? No, it's probably not. So we're gonna have to like sort it by the vowels or something. We do sort by vowels. That's not gonna work, is it? No, that doesn't even do that. We'll have to do make this an anonymous function. So we'll sort by the vowel. Does that make sense? No, I guess not. How does sort by work? We take the key function and then the collection. Yeah, okay. Returns a sorted sequence of let's just find, we'll just grab the 3, the one that has the value of 3. Yeah, this is like so simple. I'm just my brain is sludge, or just undeveloped in the first place. Okay, so we will just find the retrieve the key that equals something. So we'll say filter. I don't know. We'll test. We'll get the one where the this is so simple. We just want to if let's say we map vals on this. Wait, that's not even how it works. How we can't map vals? Oh, because that's val. Oh, okay. Map val. We actually just want to like reverse the keys in the vals. But no, that doesn't if we sequence it, now we have the keys in the vals in vectors. And we can sort it by last, right? Does that make sense? Sort by last. And so then we have the 2 and then the 3. And then we can just do test greater than or less than on the first, right? So sort it by last and then map first. If that would allow. And then we get 5, 3, and then we just need to test whether the first is greater than the second. So we would just say like apply greater than or something. And that's true. Oh yeah, that's not too bad. I actually look like not completely inept for a second. All right. So that tells us whether if it returns true, then that means there's 3 small, which means we return 19. So let's say we replace this map with the call to frequencies. Oh, I'm so happy that we got to use frequencies. That's a great function. It's so useful. All right, so I can probably use Calva to refactor this, maybe. So it doesn't look like that. Maybe thread last. Okay. Wait. Oh, that's weird. No. Whatever. So this will be a predicate function, right? Let's score for the full house category. And here where it says 19, this is going to be kind of messy, but whatever. So I'll just have like another if with, I don't like doing nested ifs with enclosures, but whatever. I will just say, yeah, if frequencies dices then return 19, else 16, right? And reevaluated that. And here we go. And cool, it passed. All right, I did it. I solved one exercise that has never been solved before in Clojure. Wow, that's like, and it only took me 2.5 hours. All right, and I used a lot of help from the JavaScript translator, except to be honest, like that actually like confused me more than it helped. All right, wow. I can't believe I actually did it. Cool. So now what I actually need to do is copy this and put it in where it's supposed to go, which is we need to make a meta directory. And this part is not going to be done by the generator because, well, the generator does not solve exercises for us. So now that's actually the hardest part of the whole process. So yes, inside Yacht, we use .meta. And inside .meta, we have one called example.clj. And in here is this. And now I will check this in. So I'll say we create example solution. Yeah. Okay. I think this exercise is pretty much done. Cool. Wow. That wasn't too bad, actually. I just I need to learn to like not beat myself up so badly. Because it's just like I'm so hard on myself. Like as soon as I when there's hard problems, I'm fine. Like if something's hard, then I don't feel stupid. It's when like I think something's supposed to be easy. It's when I have such a hard time because it's not easy. And then I just like I feel like everyone's like laughing at me at best. At worst, they would be like being filled with disgust. Like, oh my God, this person thinks they're a coder. They can't even do a simple little thing. I know it's ridiculous, but Yeah, the easy things are the hard things. All right, so cool. I'm gonna end the stream here, but like, I didn't get to the part where that I was actually really excited about, which was the zipper exercise. Like, oh my God, like nobody told me there was a zipper exercise. They should have, like, I'm a zipper girl. Okay, cool. We'll do zipper next time. And that'll be cool. So we will play some outro music, and let's see, it'll be yeah, same one. Big thanks to Closures Together as usual, and wow, it's like we're already into the second month. Oh, that's horrible. I want them to pay me forever. After this is done, I better like get some Patreon supporters or something in order to keep my lights on, or find a new project. By the way, yeah, my Patreon is Bobby Codes, if anyone's so inclined. And no obligation. Next time, we will implement zippers. We'll see y'all later. Have a wonderful day or night or whatever it is upon